Okay, so just to drive my just to drive my point home a little bit more, let's consider the limit as x approaches 1 of x squared minus x over x minus 1. Now, if I use the limit properties, notice I have a polynomial on top and I have a polynomial on the bottom. I'm going to get 1 squared minus 1, which is 0. That in of itself isn't a problem, but when it's coupled with a 1 minus 1, a 0 on the bottom, that's a problem. So we have an indeterminate form. That means you've got more work to do. Now remember what my strategy is. I want to remove a term that approaches 0 on the top and bottom when we take the limit. So that's my strategy. I want to remove some term that's going to approach 0 when I take the limit from the top and the bottom. Well, the top term approaches 0, definitely, but so does the bottom term, x minus 1. So this term, I notice that as the limit as x approaches 1 of the bottom term, this approaches 0. So wouldn't it be really, really cool if I could take out an x minus 1 term out of the bottom and out of the top? See how I'm thinking ahead a little bit? I really want to find this term and reduce it out of the top and out of the bottom. And if I do so, I'm getting rid of a term that's going to go to 0 when I take the limit. So I look at the top and I say, yeah, I think I can do that. I think I can do that by simply common factoring. So look what I've got here. I've got a term on the top that's going to approach 0. This approaches 0. I've got a term on the bottom that also approaches 0 with the limit. But before I take the limit, I could reduce them, because there's one on the top and there's one on the bottom. And once I do that, I'm left with, now remember, it's x over 1. It's not x over 0. It's x over 1. I would just write it as x, but it's your choice. And now I can take the limit of this, and this limit is 1. So I've gone from having an answer that was indeterminate. I've gone from 0 over 0. I've manipulated it a little bit. I've removed a 0 term. From both the top and the bottom, and now I get an answer that I can live with. And if you throw this into Desmos, you're going to see that it actually works. Or you can do left-handed and right-handed limits if you've got nothing better to do with your life. Okay? If everything else fails, left-hand and right-hand limits always work. Okay? You can do charts to your heart's content and you can figure out an answer. It's not what I would like to do, but it will work. So, this is the strategy. So, some common methods to deal, or to, what's the word I want to deal with? Some common methods to deal, yeah, it's not the best word, but deal with 0 over 0, the indeterminate form. Indeterminate form. And it's called that because it's a form of the answer that we're going to change. It is an answer, but we're going to change that form. And so some of the methods that to deal with, and these are the ones used in this course. Number 1 is going to be factoring. And that means all types, which you're going to love. Number 2, we also do common denominators. Number 3, we do rationalize. And in this one, we do both, top and the numerator and denominator. depending on the question. And for substitution, and one that I'm not going to talk about as a subsection, but is always true, if everything else fails, left and right hand limit charts. If all else fails, you go to your charts. Okay, I'm going to pause the video here and we'll be right back.